Hello friends, I am your course instructor Professor Anisa Shikalgar. In previous lecture we have started with the construction of DFA, the part of finite automata, construction of DFA, in which we have seen two examples how to construct the DFA. Also we have seen some rules to design the deterministic finite automata. Today we will continue with our next examples. So here one example is given to construct the DFA. Summation is equals to a comma b and the language is given a raised to m b raised to n. So students, here first we will consider which kind of strings are exactly accepted in that particular language. Here m and n greater than 0, it is not equal to, only greater than 0 means started with the 1. So the first string accepted will be the AB. Okay, here two different constants they have used, one is m, another is n. So at a single time the values of both should be the different also. So here a square b, it will be also accepted, m is equal to 2 and n is equal to 1. Similarly a b square, that is also accepted, a square b square. So here students, these are some kinds of string which are accepted in our language given. So for that language we are going to design the DFA. Okay, so in the previous video I told you what to do. First, consider the minimum length string. What is the minimum length string here? AB. What is its length? AB, the length is 2. So here 2 plus 1, students, here 2 plus 1 means here it is my observation that 3 states are required in that particular DFA. So I told you that particular formula is applicable up to 70 to 80% DFA. It is not universal formula. Here that we have understood by our whatever experience that these kind of formulas are for 70 to 80% DFA, it will be applicable. Okay, so here I am going to consider three different states. Suppose Q1, then Q2, and here it is Q3. So Q1 is my initial state. What is my minimum length string? Here it is the AB. So A, B, and accepted over here means Q3 is the acceptance state. Now what is my language here? See the students, A raised to m. Okay, so A raised to m means first A is accepted, is come at the Q2 and I want A raised to m. So suppose I can give the loop of A at the Q1. What will happen? Here it is also A raised to m, but I can't give the loop at Q1 because it is a DFA. And in the rules of construction of DFA, we have seen from Q1, if the A goes to another state, then there is a only single transition of A. Okay, so Q1, A of Q1 it goes to Q2 means another A from Q1, it is not possible in DFA. That will be possible in NFA but not in DFA. Therefore to complete A raised to m, here we can give the loop of A over here, because from Q2 still A doesn't goes anywhere. See here, from Q2 only transition of B goes, A doesn't goes anywhere, therefore I can give the loop of A at Q2. So here we have completed A raised to m, A and A raised to m. Similarly B raised to n. So from Q2 B goes to Q3. So here I can give the loop of B at Q3. So here it is students, A raised to m and B raised to n. So see here, all these strings are accepted. A, B accepted, A square B. So A, one loop is executed, it means A square, B, it will be executed. Then A, B square. A, it is optional, so I don't want to execute now. A, B and B square. Suppose that one, A cube B. A square A cube and B. That will be accepted over here. So all the strings are accepted. Okay, but what is the question, student? Here my question is to construct the DFA. So whether it is DFA, we have seen the rules to design the DFA, still it is not DFA. Why? Because Q1, from Q1 A goes to Q2. But what about the B of Q1? From Q1 still B doesn't goes to anywhere. Q2, A and B. So Q2 is complete. Q3, A transition of Q3, still it doesn't goes to anywhere. So students, to complete it as a DFA, we require to give the transition of B of Q1 and A of Q3 to any other state. So first of all, check in that particular states only. From Q1, can I give B to Q2? So suppose here we give Q1 to Q2 B transition, then what happens here? See, suppose I give B. So what happens here? B is also accepted, which is not accepted in our language. Therefore, it is wrong. So from Q1, suppose I give B to Q3, then what happened? Only B is also accepted. And also suppose I have given the loop of B, then also the meaning of language is changed. Therefore, all these three states are, I can't include the transition of B from Q1 to any of these three states. So in that case only, what we are going to do? We are going to consider the dead state. It is dead state, and from Q1 I am giving the B to dead state. All these are wrong. Directly I am giving the B to the dead state. Okay. Now here that transition is over. From Q3, A transition still it remaining. So first check from all these three states. So can I give A transition to Q1? Can I give to Q2? Can I give to Q3? If any one of these is applicable, then give to that particular state. If not applicable, then only give to the dead state. So consider, students, suppose Q3 to, suppose I have given A to Q1. What happens? So here A, B, A, B. These kind of strings are accepted. But here, what in our language? Consistently I want A. After A, I want B. So after B again A is there. Then that kind of languages are not accepted. So here also suppose I have given from Q3 to Q2, suppose A is given, then what happen? A, B, again A, B. So it is not possible. And suppose here loop is there, then that kind of strings are ends with the A. That is also wrong. Therefore here, students, the A transition of Q3 is also given to the dead state. So neglect about all these blue lines and blue symbols. Only consider what we have designed in the black color. So we have considered dead state, and B transition goes to dead state, A transition of Q3 goes to dead state. So that is our final deterministic finite automata for that particular language. Okay, understand, students? Okay, now we will move towards our next example. So what is that? The language given is B raised to M, A and B raised to N. Okay, so the language means the strings exactly accepted in that particular language B, A, B, because M and N greater than 0. Here also two different constants they have used. Therefore, B square AB, B, AB square, B cube, AB, likewise all strings are accepted. So the students here, minimum length string 3. 3 plus 1 means 4 states we require. So suppose here now we consider A, B, C and D. Any names you can give to your states which we have considered. A is the initial. The minimum length string is B, A, B. So D is our acceptance state. Same kind of example it is, but only here B raised to m A, B raised to n means I want only single A. Okay, at any cost in the particular language, the strings which are having only single A, before that A any number of B's, after that A any number means whatever according to the constant. Okay, so BAB is the minimum length string. So for B raised to m, what we are going to do, from A B transition goes, therefore B raised to m we have completed like this. Okay, B raised to m A and students here B raised to n. Same kind of example it is. Therefore, I have given here constantly that particular, after that example we can consider that. Okay, so B raised to m A and B raised to n. Then students, now still it is not DFA. To complete that as a DFA, what we require? A transition. Then here from that B and A both goes, C still A is required, and D, here B is given, A is requires. Okay, so where I give the A transition of that capital A, students, can I give to B? No, because if I give to B, then AAB, that kind of strings are accepted. So can I give to C? It is also no. If I given to C, only AB is accepted, and directly if I given to D, only A string will be accepted. Therefore here it is the dead state I have considered, and the A transition is given to dead state. Here for B, A and B both transitions completed. From C, B is given, A is remaining. So you can check that A transition we can't give to any of these four.